Okay, now that you know how to do it, let's put it to work and actually do it. I have a large variety of problems here, so I'm going to try to do them quickly so the video is not too long. I want to show you all the different possibilities when you're graphing these absolute value functions. We'll start with the most basic one, y equals absolute value of x. They call it the parent function. It's the basic one and it has nothing changing it. Because if you take a look, the a value is 0, so it's not going to shift the vertex to the left or right. The b value is 0, it's not going to shift the vertex up or down. So the vertex is going to remain at the origin. So I'll make my vertex point. The problem says, click to plot the vertex first. And take a look, once I start moving, it starts making my v, see it? So now I need to make my second point to the right, which is based on the slope. The slope here is 1, so therefore from here I will rise and run 1 and take a slope of 1. Just a real quick check. At this point, I inputted 1 for x. See, the x value is 1. So if I input 1 for x, the absolute value of 1 is 1. Y should be 1, and y is 1. That's how you can check yourself. All right, so far so good. Absolute value of x, and then minus 8. The a value is still 1, so I'm not going to shift left or right. But the b value is negative 8. That means that my vertex point from the origin is going to shift downward 8 units. Right down the y-axis, and there it is at negative 8. There's my vertex point. And now according to this, my slope is 1. So from here I will rise 1 and run 1. And there's my point, and see how it reflects it for me. If you were to input 1 as your x value, you should get negative 7 as your y value, to check yourself. 2 for 2. Absolute value of x minus 2. This time I have an a value. An a value inside this absolute value depends on how you look at it. The formula is supposed to have a minus. Therefore, that means the a value is 2. I look at it as if there's a negative 2 inside the absolute value, I go in the opposite direction of that number. So if this is a negative 2, I'm going to shift to the right 2 units. And then there's no b value, so I won't shift up or down. So I'm just going to start my origin, shift to the right 2 units, and create a vertex point. And then my m is 1. So I will just take a slope of 1 to the right, and there's my point. And I'll check this one real fast, just because it's a little different. This time, my next x input right here is 3. So if I take 3 and put it in here, 3 minus 2 is 1. The absolute value of 1 is 1. The y value should be 1. Well, the y value is 1. My graph is good. All right, the absolute value of x plus 3, and then plus 1. Now I have an a value and a b value. I'm going to have a multiple shift of my vertex, of my v. Inside the a value, this plus 3 says I'm going to shift to the left 3 units. Outside, this b value of 1 is going to shift up 1 unit. So I'm going to shift left 3 units, up 1 unit, create a vertex. And then my slope here is 1. So my slope is 1 to the right. There's my next point, and I'll double check this one too. My x input will be negative 2 here, according to this point. So if I input negative 2, negative 2 plus 3 is 1. The absolute value of 1 is 1. And 1 plus this 1 makes 2. The y value should be 2. I think I have a winner. All right. 5 times the absolute value of x. My a is 0, my b is 0. That means I'm not going to shift my vertex anywhere. My vertex will remain at the origin. But now I have an m value, a slope that's not 1. My m value is 5 outside of this absolute value. That means that I'm going to have a rise and run of 5 over 1. It's still a v, but it's a skinny v now because it's growing at a 5 times faster rate. Well, let me just double check myself. My input here would be 1. Input 1, absolute value of 1 is 1, and 1 times 5 is 5. Output is 5. I've got a winner. Same concept for this one, but now the m value is inside the absolute value. So it's going to sound different, but actually work the same. First, let's work with my vertex. A is 0, so I'm not going to shift left to right. B is -2, so I'm going to shift my vertex down 2. There's my vertex coordinate. My m, well, I'm going to take this 6 coefficient and take it out. So the absolute value of 6 is 6. Or I can just leave it in there if I want, the absolute value of 6x. The slope is 6. So from here I have a slope of 1, 2, 3, 4, 5, 6, and run of 1. And there's my v. What if that m value is negative? -3 times the absolute value of x. Vertex first. Always vertex first. A and B are both 0. A and B both 0, so the vertex is still at the origin, didn't go anywhere. But now my m value is -3. So you can look at it two ways. You can either say, well, the negative is going to reflect it down with a slope of 3, or you can just say that the slope is -3. Either way, if I start here, reflect down, and go 3 and 1, it's the same as starting here and going a slope of -3 over 1. Same idea, same point, same graph, same right answer. Now my negative is inside the absolute value. Little bit different, but vertex first. A is 0, won't shift left or right. B is -4. My vertex shifts down 4. There's my vertex coordinate. Now, this -5 is the m, but it's not really -5 because it's in the absolute value. So the m on the outside is a positive coefficient. There's a positive in front of the absolute value. So it's not going to reflect downward. It's going to stay facing upward, the v. Because basically you can take this -5 out of this absolute value and make it +5, because this is a multiplication operation. You can't do that with addition and subtraction, but you can with multiplication. Multiplication has its own little set of rules. But since this is going to become a positive, and the slope is 5, from here I will just go up 5 over 1. And I don't feel as confident this, and so I'm just going to double check myself. It's always a good plan to check yourself. At this point that I made, the x value is 1. So let's input it. X is 1. -5 times 1 is -5. The absolute value of -5 is 5. And then 5 minus 4 is 1. Y should be 1. Y is 1. So my theory worked, where this negative being inside becomes positive, and the slope goes upward. Correct. Couple more now with some multiple shifts, and then an added little tricky bonus. 4 times the absolute value of x minus 4 minus 8. Always vertex first. The a value here says I'm going to go to the right 4 units. And the b value says I'm going to go down 8 units. So my vertex is going to go right 4, down 8. Here's my vertex coordinate. And now I have an m also. My m is 4. So that means that from this point, my slope is going to rise 4 and run 1. I think that's my next point. There's a lot going on here, so I'm going to check it. At this point, my x input right there is 5. So if I input 5, 5 minus 4, 1. Absolute value of 1, still 1. 1 times 4, 4. And then 4 minus 8 gives me -4. And that's where it is. You could input this number if you want. Watch this. 3. 3 minus 4 is -1. Well, now the absolute value of -1 is +1. 1 times 4 is 4, and 4 minus 8 is still -4. See the repeated numbers on both sides of this axis of symmetry down the center. Think my graph is good? They think so too. All right, vertex first. -7 in here says it's going to slide or shift 7 units to the right, and then 3 units down. So my vertex is going to go 7 right, 3 down. Vertex set. Now, outside of my absolute value is a -3. That means that either from here my slope is -3, or my my v is going to reflect downward with a slope of 3 or 1. Again, a lot going on here. I'm going to be safe and double check myself, especially if my SMART score is this high. I don't want to mess it up. My input here is 8. You could take this input too if you want. You could use 6. They both should get you the same answer. But if I input 8, 8 minus 7 is 1. Absolute value of 1, still 1. 1 times -3, -3. And -3 minus 3 is -6. This should be the point -6, and it checks out. Those are the easy ones. Last but not least, here's a trick, a harder one with a little something else going on. The absolute value of 3x plus 15 plus 3. So if I look inside my absolute value, I see what I think is the a value of 15. So I think I have to shift left 15 units. Well, my graph doesn't go that far. So that can't be right. There's got to be something else going on that's going to make it fit. They wouldn't give me a graph here if it didn't fit. And here's what it is. Look inside this absolute value, 3x plus 15. That has a GCF. So you're going to have to factor your GCF out of that binomial in the absolute value. The GCF there is 3. So my new thing is going to say absolute value of 3 times x plus 5. Close your absolute value. And then plus 3 at the end. Well, now I have the a value inside of this parentheses that's inside of the absolute value. This only works when that coefficient of x is 1. Then that's the a value. The coefficient of x is not 1. You need to factor it to make it 1. So now I have an a value of 5, so I'm going to shift left 5 units. A b value of 3, I'm going to shift up 3 units. So I'm going to go left 5 units, up 3 units, and that should be my vertex. And then my m value is that GCF that I factored out. If I want to, I can remove that from the absolute value because this is a product, a multiplication. But if you don't think about that, if you just say, well, the m is 3, that means from here, my slope should rise 3 and run 1. Well, there was a whole lot going on now. I'm definitely going to check myself. So let's see. This value right here I inputted is -4. So if I input -4 for x into my function, let's see what happens. 3 times -4 is -12. -12 plus 15 is 3. The absolute value of 3 is 3. And then 3 plus 3 gives me an output of 6. So at this point, my y value should be 6. And it is. Look for that GCF. As you get to the end of this IXL, it'll be a 90 and plus on that SMART score. As you get to the end, if you have a GCF inside of this absolute value, you need to factor that GCF out of that, keep it in the absolute value, and that GCF becomes your M value. And then the A value is what's left over after you factor out that GCF. All right, let's just double check. That's right. Looking good. Good luck.